Okay, let's start. I am recording, and as people join, we can just fall in. So basically, just going to do a quick recap on study unit 2 that we did last week, and then we can go into study unit 3. So last week, we actually only looked at the problems. And I thought what I added to this deck is also some more of a theory. Let me just see if I can you guys let me quickly check if I can. Does it allow me in the apps in the chat to? Oh no, it doesn't allow me to. I was wondering if I can add a file or something. It doesn't seem like it. So what I'll do after tonight, I will just make PDFs of the first 3 sessions and then put it onto our WhatsApp group as well. And then I'll just see how I can share it within the chat that everybody has it as well. Okay. So basically on study unit 2, what I've included is just a lot of definitions, and things that one might come across. So I think last week we talked about the frequency distribution. So I wanted to actually do one. So let me use this data set, and let's just go through all the things that you might need from a distribution set. So we'll do the categorization of it. Then we will say how many there are. So we'll do basically the frequency. I just want to write it down. Then we'll do the relative frequency and percentage. We can also do percentage frequency. But then I also want to check, I want to add the cumulative, which they don't have in here, and then a percentage to that. Okay, so let's do that. I'm going to use that. And let's just see what do we need in it. Got 1, 2, 3, 4, 5. Let's can always delete if I have too many. Okay. So we will have a frequency. We will have a relative frequency. I will sort out the spelling later. Percentage frequency, relative frequency. See, and let's also add the percentage cumulative. Let's just quickly. Okay, so basically, the things that I said last week, I quickly wanted to do a table like this. So um, let's just get it a bit nicer that we can see within. Okay, so then let's see, there's probably a below average. Okay, and let's basically count how many there are. There's 1, 2, 3. You can also just check. So let's say I assume poor is worse than below average, but below average there was 3. Poor result there was 1, 2. If I missed something, just shout. What? Then I assume it's average. Let's see how many averages. There's 1, 2, 3, 4, 5. Then there is above average. 2, 3, 4, 5, 6, 7, 8, 9, and 1. 1 excellent. Okay, let's quickly check. Okay, so it seems like it was right. So we'll just move it to there. And then the total was 20. Okay, so relative frequency will just be 2 divided by the total. So for your below average, it will be 3 divided by 20. Above average, 5 divided by 20. Above average, sorry, the other one was average. Above average, 20 or 9 divided by 20. Excellent, 1 divided by 20. And if you add all of that up together, it should be 20 divided by 20, which will give you 1. Okay, so your relative frequency will be that, and you can also write it as a percentage. So you can write it as 0.1. So in assignments and in tests, they can give you all the fraction, or you can write it in the decimal format. So here you also see they actually had it in the decimal format, but you can write it into any one. So depending on what they give you in the assignment or in the exam as the final results, you can then see if it is a decimal or a fraction. So then the relative is just that 0.1 times 100 to make it a percentage, which will then give you 10%. Also, what you will see is if you then add all of the relative frequencies, it should give you, the sum will give you 100%. So let's quickly see if we can just get that. So I would assume that is 15%. 5 divided by 20, 0.25. That is 25%. 9 divided by 20 is supposed to be around 0.45. We'll see now if that is also correct. 1 divided by 20 is 0.05, which is 5%. Okay, so it would have been 10, 25, 50, 95 plus 5 is 100. So that total will give you the 100%. Okay, so then sometimes, and it's better if one works for cumulative frequency when it is numbers, to say, well, more than, if you want to say how many is above a certain height or a certain weight. But what one can also, because this is results, one can always say, but you can always look at it from a cumulative percentage to say, okay, how many is as at poor results, then how many had below average and poor, how many had average and below that, so that one can get the cumulative. The first one is always the same as the relative. So those two always the same, the first one. The same with a percentage, it will always be the same. So then cumulative, add the next one with, so let's quickly do that. So all that I do is I add the next one to it. So it will be then 0.1 plus 0.15, which will give me the 0.25. Okay, so in a percentage, that will then be 25%. So now we go to the next one where it is 0.25 plus 0.25, which is 0.5, and then as a percentage, it will be 50%. So basically, we could see that in these results, whatever results it was, that half of the sample had average or below marks. So then the next one, 0.5 plus 0.45, which is equal to 0.95, which is 95%. And the last one is just adding the so once again, when you get to your cumulative, you will see that it then also, the last one should then also make sure that it's 1, or if it's a percentage, it's 100%. As I know, we spoke about this last week that I wanted to show it. So I thought, since we are going through some of the definitions of what each one is, it's maybe a good time to quickly throw this into the pot of the example. Okay, so just to recap, we can, and that's why I also will again share this, so that if something like this is in the exam, what the definitions are, I don't remember what these definitions are. It's not needed if you have it on a paper. So I think it is just there so that you can have it if they are something like this in the exam. Okay, so again, just adding nearly all of it into one. So that's the frequency tables that last week we nearly only looked at stem and leaf. So this is one of the other ways is the frequency tables. What they do like to ask is they like to ask this. So um so there will be something like this in your assignment. It might not be that it is categories that they are talking, but it might be that it is numbers. Um, so that is definitely part of it. The other thing that they normally want to throw in is bar charts or and let's just take it. So you could have analyzed this frequency by looking at it as a bar chart, and then it is just the normal, the 2, the 3, there was the 5, there was the 9, and there was the 1. So just instead of doing it as a relative frequency table, it could have been presented in a bar graph as well. Then I think the next one should have been a pie. So again, nearly looking at the same information. With a pie chart, we're always looking at the percentages. So if you again look at it, where we had the 10, 15, 25, all of that. So that would have been nice to put in a pie chart. So if you look at the pie chart, there's the 10, there's the 15, there's the 25, the 45, and the 5%. So things that, and again, what just might happen is that for both of these, they can tell you or ask you which one has the highest incidence, or they can say, um, pick the one that is wrong or is correct and say above average is the least number or something like that. So they can nearly give you one of these graphs and then ask a question around it so that you need to interpret the graph. Um, so yeah, but I think what's important nearly is with this set of, where was it? No, that's this set of data. You could have done a frequency table. You could have done a bar graph. You could have done a pie chart. So there's so many ways of doing it. And I think that is nearly also important is there's no, if you look at that, really a right or wrong method if you look at those charts. So you just need to understand that all three of them nearly look at the same data. The thing that they also like to ask in the assignment is they give you this huge set of data, and then they ask you to put this into a diagram. So the first thing that you need to nearly see is how many classes and how you're going to break it up. So what I normally do, and let's do this. Let's get that set of data. I'm gonna open a Excel. I'm just hoping that if I copy this in, that it will be okay. No, so that is unfortunately not as easy. It is in a picture already, but let's do it like this. Okay, so I'm just sure this is a lot of data, but don't worry. Let's I was hoping I could just copy and paste it into it, but it seems like it is. But at least we will be able to use this spreadsheet again. So, um, so again, what for me is easiest normally is how I would do this, and let's do it the way I would have done it, so that you can use it in your exams as well. I would need to get a minimum. Need to get a maximum. There's classes. There's class. And just get all the other names in as well. Okay, so that's fine. 91, 78, 93. If I miss a number, just shout, please. Okay, so that's the first line. And again, as you would see, I rather work with Excel. You are allowed to use Excel. You are allowed to. It's also open book, so no issues at all. You are allowed to use my Excel formulas as well. So it's not that you now need to go and create it yourself. You can just use what I have, and whenever there's a new set of data, you can put it into this. Okay, so while I'm doing this, we are recording this, so also you can look afterwards. You can look at it. I'm also probably gonna load it onto YouTube as well, so that you can just, if you need to get it quicker for when your assignments are due, it will be there as well. Okay, so we basically have this set of data. I hope it is correct, but it will be fine if we will be close enough with the answers in any case. Okay, so we've got the sample. So I just want to find out what is the minimum value. And I tell it to look at that set of data. So the minimum is 52. Maximum, see, there is maximum. So the maximum of that should be 109, I think. Okay. So we've got the minimum, we've got the maximum. So when we go into this and we need to design this table, the one thing that is very important, and I think it, so you get the set of data, they need to, there's one thing that they need to add to the question. So they can't just tell you, here's the set of data, create a frequency distribution. They need to tell you how many classes you need to create. So they need to tell you, you need to divide it into how many classes. So they want us to divide it into 6 classes. Okay, so they need to tell us how many classes. And I think that is very important. So this part of classes they need to give you. because else I can decide I want to use 7 clauses, I want to use 4 clauses. So that is the one thing that they need to specify for you. Else you can actually have anything. So when we know how many clauses there are, we can work out the class width. So let me also just copy that in. And I'm not gonna all of that. I'm just gonna say that. Okay. So, and the class width is basically looking at the maximum minus the minimum divided by how many classes. Okay, so the class width is around 9.5. So again, we will round that off to the nearest full number, because again, I'm not going to work with a class width of 50 to 61.5 or something like this. Again, please round it off. So we then work with a class width of 10. So now that we work with a class width of 10, you can see what's the easiest is to say, okay, but you're working now with 10. So your top one is 109, your bottom one is 52. But again, you don't want to work with 52 to 62. So again, what I would do is, because you're working with those numbers, you could have, the easiest way again to look at it is to say, well, what was that difference between the highest and the lowest? So it was 56. So 56, or sorry, 57. So I would then say, okay, but let's start with 50. So that your first one is 50 to 59, which is 10, a width of 10. And then it's easy if we do it like this. What is also important nearly is, depending on how the data is, and I'll show you now what I mean by that. We don't have a 59.5. Okay, so there's other ways that one then could have said this data needs to look like. So if it is that there was, say, a 59.9, the way we would then show the data is to use certain brackets. So then we would have said, let's go to 60, so that it includes 60. But then your next one is anything above 60. So if you then had 60.1, it would fall into your next set of brackets. So what I will do is I will get, and thanks Darby for the form that the students please just need to the attendance register. So what I will also send you guys is just a few ways how we can write the frequency tables, when something is included, when it is excluded, all those kind of things. Okay, so then what we do is we need then to complete the rest of the table to get the frequency. So unfortunately, let's see, is there a formula that can ask us see if it is there's sometimes a formula that one can use, but if it's not working, we are going to need to just count it as normal. That I wanted to say 259, but that is not, it's actually doing with sum. I will get us another one to do that. But okay, let's, out of that data, let's quickly, I just want to see another formula. If we could have ranked that data. And see, I'm trying everything that can make it easier for you guys. Doesn't seem like you know, we need to do it the hard way. It is not, I will check if there's later on. Okay, frequency of how many are between 50 and 59. So unfortunately nothing there, nothing there, nothing there. So that was the first one, 57. So 52. So I get it as 2. I'm going to add in here total. So that at least when you need to work out the total, we can do that. And then for the frequency, relative frequency, we can work that out as well for you guys so that we have it in there. Then we can have a percentage relative frequency as well. Link it so that you guys can, whenever you need it. And let's add a cumulative. Cumulative frequency and the percentage the frequency. When you nearly are sorted for all of the possible things that can happen. Let me just do that. So the next one would be that plus that. We will now see if it all pans out. Let me just do as a percentage. Okay, so let's see if this will work. Okay, so anything between 60 and 69. So there is 1, 2, I miss something, just say 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Oh, we can always just add. So you can see automatically the relative frequency we've adjusted. You can see relative percentage adjusted, cumulative I have adjusted. We will just check if that is right. This might be wrong, but that is fine. We'll get that formula sorted out now. Okay, all the 70s. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so I get 16. Everything between 80 and 89. 1, 2, 3, 4, 5, 6, 7. And 90, between 90 and 99. 1, 2, 3, 4, 5, 6, 7. And then last, that's more than 100. 1, 2, 3, 4, 5. Okay, so there is our table, our frequency table. So we've looked at it, we've divided into 6 classes, each with a class width of 10. We went to count the frequency of each one, the total, so we know that there was 50, so the total is right. We've worked out the relative frequency of each one. It should add up to 1, so that's fine. We worked out the percentage relative frequency or relative frequency percentage. They ask us that. Then we worked out, and let's just see, so that is what we should have added here is we want to work out the cumulative frequency. So it should be, okay, let's see. And let's put in there 0. So the next one should be see if that now is better. So that's just a placeholder, so it's that. And the next one would be 15 because it's 2 plus 3, it's 15. 15 plus 16 is 51, and so forth. So that's fine. And then that should just be a percentage. So what we should have done here, you just make sure that you can, when you use it, it is correct. See, okay, now it's not because now it adds the wrong one. So it should then rather be cumulative frequencies is first is just that. So it's not relative or anything. So I made a mistake again. It should just be that we haven't. We're just adding everything. So here it should be. And this one, we should just make sure that it is a percentage. Cool. Okay. So this you can also then use for when there is other things that you need to link to the tutorial. I wonder, is the tutorials up for you guys yet? Has it been open since there's now a question on it? Have it been tutorials been opened? Or is it only opening next week? I just see that comment in there. So whenever you can reply. But okay, so this is, you can use this. So if you now get a set of data that is a bit different, you can always change that data and it will automatically change some of the things. So just you can use this. Okay, so that's nearly looking at a frequency table that you can work with. Again, in the frequency table, because this one is to do with numbers, we can put it in a histogram. We could have done it into a dot plot. But what you would probably get in the assignments and exams is the stem and leaf that we did last week, the frequency table, and then a histogram or a bar chart or a pie diagram for chapter 2. Dot plots not really happening, so they're not really going to, in the first few chapters, talk about regression lines, so that you also don't need to really worry about now. This is also coming at a later stage, so for the moment, I think those are the bigger ones that you need to know. So they can show you a bar chart like this and then ask you questions around it. So they can ask you for whatever eco's standard for. They could say, here is 4 statements, which one is incorrect? And they could have said, well, eco is higher for that amount, where Scandia is lower. So again, looking at the data, they can ask you some questions. I also thought what is just good to see, and again, this is more for later on, so I will repeat it when you do regression lines as well, but how sometimes they talk about a positive relationship, a negative relationship. If there is no real relationship, it's actually more to do when you get to regression lines, but because we also have a subsection around scatter diagrams, they can ask it here as well, but most likely only in the later chapters. Okay, so let's get into and when I just made a summary of nearly all the possible things that can be asked. Um, so remember when we started off in study unit 1, we spoke about qualitative and quantitative data. So this is just, again, the different things that they can ask you in a definition question. You use a pie chart and a bar graph and a frequency distribution to show qualitative data. Or they could say, I use those three to show quantitative data. And you need to say which one is right or wrong. I have seen a question like that in one of the exams, so that is why I thought I would include it in here, just so that you really can see what is qualitative and what is quantitative. I would nearly, for most of the instances, focus on these that you know them, so that you know that quantitative is those four options, qualitative is those four options. The rest is nearly the same. So you've got frequency distribution in both. You've got relative frequency in both. So I'd rather focus on the ones in pink nearly, because that is where there is a big difference in what the data and how they can represent it in a format. Okay, so that is nearly just again a summary of study unit 2 and some of the definition work that can come also with study unit 2. Malusia, I see you ask about the link to the tutorials. Is the tutorials open already? And that's just, it's normally about 2 weeks before hand in.
Oh, thank you. I'm now in the training. Thank you.
Okay, cool. Okay, perfect. Okay. So the other, so let's also start then with study unit 3. It is still being recorded, so I will share the recordings afterwards in any case. Also, if you want to join the WhatsApp group, please send me a WhatsApp. I don't know if it was in the previous, so let me just copy this into the chat as well, so that you have time to send me a WhatsApp or email or anything like that. Okay, so study unit 3, and this is again, so study unit 1, we talked about the different types of variables. Study unit 2, we talked about showing some of those variables into graphs and diagrams and things like that. And now with study unit 3, we're adding some more information to it. So now we're gonna say, but yes, we look at the graph, we see the data, we look maybe at the stem and leaf, we look at the bar chart, but we want to say more. So we want to say, where is the most of the data lying, or is there outliers in the data, or what's the mean of the data, all those kind of things. So study unit 3 basically is taking study unit 1 and 2 and adding a bit more to it to say, but let's analyze the data a bit more. This is nearly a summary, but there is lots of summary or slides on it as well, so I'm not going to go too much into that. I want to start just looking at some of the examples again and some interesting things again of how they can try to not catch you out, but in a sense, look at certain answers. And because a part of the answer is in the first one, you nearly say, okay, this is correct. And you might not look at the full set of options. Okay, so if we have time, I will also go through the definitions and the theory and those kind of things as well tonight. But okay, so the first question is about, they tell us that we have this distribution which is symmetrical, and just assume that what I have drawn is symmetrical. Um, let me just get, so something like that is symmetrical. So the one definition of something being symmetrical is that that top point there, um, the mean, and I don't know why this is doing this, the mean, median, and the mode is all the same. Okay, so for something to be symmetrical, those three need to be equal. So it doesn't matter what the number is, if it is 70, 80, 90, 1, 5, 6, whatever, but they all need to be the same number. Okay, so for something to be symmetrical, those three need to be the same. Okay, so let's look at what the options are. The value of mean, median, mode are all equal. Cool. I like that. In the exam, I would have said, okay, done. The first one is the correct option. Let's just see what are the other things that they give us. We use the sample to conclude about the population. So we do use a sample to conclude things about the population. So yes, it's true, but that has nothing to do with if a distribution is symmetrical or not. So that, to link it to distribution symmetrical is wrong, but it is a right statement if it wasn't the question. Um, each observation in a sample is likely to be selected. Again, that is a right statement if we were talking about a sample and the sample selection and things like that. But again, nothing to do with distribution of a symmetrical. So again, wrong. The value of a mean, median, and mode are not equal. Okay, so that is definitely wrong because it should be equal. We are able to calculate the mean and the standard deviation through the calculator. Again, yes, we can. There's nothing in that sentence that is wrong, except it does say nothing about if something is distributed symmetrical or not. So again, in the exam, if you looked at this, all three of those statements was actually not wrong, but it has actually nothing to do with the question. So sometimes again, when you are rushing, and you haven't read what the question is, you might have answered any one of those nearly as correct because it's not really incorrect, but the incorrectness is it has nothing to do with the question. So again, when you guys are doing the the assignments and the exam, just be careful when you do it. Again, with stats, you can't. So if you've now done question one, you go to question two, you can't go back. So just be careful when you read it the first time that you read it correctly. Okay, so now we're going into a bit of analysis of the data. So they give us a set of data, then they ask us questions around it. So let me, as always, I want to try and see if I can use Excel. So the first thing when I work in Excel, you don't need to, when it's in Excel, need to order the data. But for me, I normally do order the data so that I get into the rhythm of doing it. But in Excel, it doesn't matter because in the end, it will still work out what the correct answer is. So let's just make sure I've got 26, I've got 27, got 28, I've got 50, 51, 51. Okay, so how do we work out the range? The range is normally the minimum minus, or the maximum minus the minimum. So let's see what was the max. The max in that data set was 51. The minimum in that data set was 26. The range would have been your 51 minus your 26, which is 5. I just want to check if there's not a range. No, there's not a range function. Okay, so range is 5. So we could see out of these ones, okay, the range is 5. Correct. We go on to the next next question. But let's also ask Excel to actually work out the mode for us. Okay. So the mode is 51. We can see there 51 because 51 is twice all the other numbers is 1. So mode of 50 would have been wrong in any case. So let's see what else do they ask us. The median. Let's work out the median. So median is the number in the middle. If we look at those numbers, 26, 27, 28, 50, 51, 51, the median, if I look at that, will be probably between 28 and 50, so it should be 29. So the median is 29 and not 28. So if, and this is where if you look at this data and if you haven't ordered it, you would have said the number is between 26 and 50. And the number between 26 and 50 is 28. So just very careful that you need to order the data. They could have even had that the range is 0 because, again, one could have said if you didn't order it, 51 minus 51 is 0. So just again, very careful of what you are looking at and to order the data. The mean is actually the average, so there isn't a mean function, but there is an average function which is exactly the same as the mean. So if you work out the mean, you will see it is one with a lot of decimals. So they say sample mean is 28. So if we rounded it off, it is 29. Okay, so then, like we had in the first one, for it to be symmetrical, the mean, median, and mode should have been all equal. It is not because the mode is 31 and not 29, so it can also not be symmetrical. So again, for the three to must be equal to one another for it to be symmetrical. So let's just add it here so that you also have it. Okay, so that you have that one for later on. So again, if you then, I'm just going to say mean median mode, and you can use this for any of any other sets of data. Okay, so if you then add new data, it will automatically change. So let's see if there's another question around this that we may be looking at. Is that the same question? Let me just check what happened here. That was one question. Okay, I think I duplicated it now, so let's just make sure. Okay, so that was, if I look at data, I think here is another one that I will again include into that spreadsheet. But first, definition one. So measures of central tendency. Measures of central tendency is basically everything that has to do with mean, median, and mode. But let's now, because now we see where they talk about it, here they talk about it, here they talk about it. So let's see what the other things are so that we can just get to the right one. Okay, so measures of central tendency include the value of a mean, median, and mode. Okay, perfect. That is fine when they have all the same value. Okay, so the value of mean, median, and mode is correct for central tendency. If they are all the same, then it's symmetrical. So it does not need to be all the same to still measure central tendency. So that part that they added actually makes it wrong, because now they're saying to us that you only can have a mean, median, and mode when they are the same, and that's not true. So we'll get to data that is, so if I looked at here, this data, we could analyze mean, median, and mode. Yes, it wasn't symmetrical, but the mean, median, and mode actually showed us the central tendency. So that extra part is what makes it wrong. Measures of central tendency include the presence of outliers. It does, but it's not influenced by that. So the only one that's influenced by an outlier is the mean, but not the other two. So that's why that is also wrong. Measures of central tendency include whether the distribution is symmetrical or skewed. Well, what is going to show that is also the standard deviations and those kind of things. So that is not the pure measurement of central tendency. Sample size, mean, and variance. Variance is to do with dispersion, not with central tendency. So it's only the mean there. So again, not correct. So measures of central tendency include mean, median, and mode, which is the correct one. So again, slight changes in the question can make it very difficult and can make it that one gets it wrong. And I think that is again important because very easy to select that first one because it gives you everything, but it gives you too much. So just be careful with these types of definition questions where they try to nearly catch you out. Okay, let's do another one like this. What I'm going to do is I'm going to create another. Wait, is it just now taking create a copy? Okay. See if it okay. So what I'm now doing is so using the same sheet that I have had before, I'm going to put it in as they give it to us. I'm not going to order it. I'm just going to put it in as they give it to us. Okay, so there is your data set as it's there. I was too lazy to order it, which is also fine. There is a function in Excel that can actually order it for you. So I could have then just said from smallest to largest and it will order itself. So again, but as you would have seen, it didn't change at all any of the answers, if it's ordered or not ordered. Okay, so the first question, look at the range. The range was 5. Here it said 0. So now that one that I mentioned in the previous one, where they said 27 minus 27, 0. So obviously that is wrong. The range is 5. The median, 29. We worked out a median as, so again, if we now need to have it as, so median is 28, so that one is also wrong. The mean is 20.17. Okay, so don't know how they got to that one. So, okay, 28.17. That definitely something weird there. Mode is 27, correct. The unordered data, so that is for ordered data actually. So that's also incorrect. So the mode is 27, which is the correct one. And again, if you now would have looked at it like that, for symmetrical, the three should have been the same. So if I ask again if it was symmetrical or not, it would not have been because your mean, median, and mode are not the same. Even if it is out by 1, it is out. So I think that is just important. But you could have seen now, ordered, unordered in Excel, it gives you the same data. But if you work it out by hand or anything else, please order the data, else you might make a mistake in the answers. Okay, let me just first stop here. Any questions from your side? And when does it make it a bit easier and simpler as we go through it? Okay, no response when I'm starting to get worried, but if it is, at least make it a bit easier. I hope it does. Okay, cool. Thanks. Okay, so so you would see I like to nearly throw in a few of these definitions or theories just to make sure that one covers that as well. And again, there might be so many different ones that they can ask, but I just thought it again an interesting one. So here we talk about the mean. So in a mean is the same as average. So you can look at the mean as basically if it's numbers, adding all of the numbers and dividing it by how many numbers there was. So let's see if any of these make sense. The middle score, if you line the score up from the lowest to the highest, so that is not mean, that is median. Let me also just say if they ask something about median, that is the median. The central tendency of a distribution, well, that is actually right. We also need mode and median, but that is one of it. The most frequent score in a distribution, okay, no, that is mode. One high point that you are sure about. I don't even know what this is. One high point that you are sure about how spread out the scores are. So that will be your standard deviation. That is not about central tendency by dispersion or variance. So or it could even be a range that it, so definitely also no, not that one. So it is option 2 about central tendency of a distribution. So again, very interesting is the other one where they added median and mode. So here they are specifically around the mean, and the mean is one of the measures of central tendency. If I swapped it around to say, what are the measures of central tendency, then it is mean, median, and mode. So just again, careful of how they structure the question, and then what you need to answer. Okay, let's go into another set. So here we start to look at not median, mode, and mean. The next thing that we normally would add is if you look at quarters, so Q1, Q3, those kind of things. And then I think the last question nearly will be on variances. So again, we can look at it on this way. I would like us to again rather work with Excel, just because for me it's easier also to sometimes just show it on, or we show it in Excel. So what I would do is I'm gonna do that because there's more data. We will just change that, and let me just also see if I can, where is my view? Let's make it a bit bigger. It's at least a bit bigger so that, okay, so again, I'm just going to read off the data first, then I will change it in. You can see as I type the numbers change at the bottom, but we'll move it back now and then work with the right sets of data, because obviously that is referring to other things. So let's just check 26, 28, 20, 21, 22, 25, 18, 23, 15, and 50. Okay, so I just want to add in the formula the full sets. Okay, so you can see that this data is definitely not ranked at all. So the minimum should be 15, the maximum should be 50, so at least the 50 is in the right, but the rest is definitely not ordered. So if we start working out Q1 and all those kind of things, we definitely gonna get wrong answers. So let's order the data. Again, in Excel, very easy. There is a sorting and filter function in Excel that you can say from smallest to largest. We're doing it, you would have seen nothing have changed in some of these things. So smallest 15, biggest 50. So at least now the data is ordered. Now we need to work out two things. So we need to work out the position for Q1, position for Q3. So let's just go back and so to how to work out those positions, and I will now put it into the Excel as well, is so when we work out position for Q1, the formula is n plus 1 divided by 4. What I normally, when I explain it, I want to add that 1 in front to say 1 times, just because for my reference there. So when we do Q2, divided by 4, and Q2 is also your median. And so just Q2 is also your median. So sometimes they will ask you, like in there, but let's just, and then Q3, it's 3 times n plus 1 divided by 4. Okay, so these are all the positions. So what I normally would also do in here is to say, okay, but let's position Q1, Q2, Q3. So again, we're going to work it out. So it is 1 times, what was it, n plus 1. So I'm going to add it there. So that is going to be n. I'm going to show you now what I'm going to do. N plus 1, and that is divided by 4. So I said that's n. Okay, so let's just make that n. We can just count how many numbers there are, and it's supposed to be 10. Okay, so that is just for your n is 10 because there's 10 numbers. So for Q1, it was 1 times, as we said, n plus 1 in brackets divided by 4. Q2 The only thing that will change is that will become 2. And for Q3, let's just change that. Obviously, we also still need to multiply. Okay, so now that is the position for Q1, Q2, Q3. So let's first look at these before we actually work out the next one. So position of Q1 is 2.75. Correct. Okay. The value of Q2 is not equal always to median. Okay, that is incorrect, because we know that the median is always equal to Q2. That's a given. It is always the same. The position of Q3 is 8.25, which is correct. To calculate the value of Q3, rank first the values from smallest to largest. Correct. We needed to do that. And the interquartile range is 6. Okay, so let's first work out. So that was the position. Let's see if we can get the value for you guys into this as well. Let's see if I have returns for quartile of a data set based on a percentage. Okay, so let's see. So we've got the array data. Returns for the quartile of a data set based on percentage. Okay, so let's just see if I say that if it is going to be okay, so if it's not that, oh, first, okay, first quartile is 1, second quartile 2. Okay, so instead of, okay, so that would have been your first. If they ask us for value, it would have been 19.5. So this value for Q2 should be the same than the median. Okay, so this value, if we work it out, then should be the same as the value of the median. So let's see if it is like that. Okay, so let's just see if that is, okay, cool. So 22.5, 22.5. So again, we can show that Q2 and the median is exactly the same number. And then to work out Q3, we have that. Okay, so then they ask us the interquartile range. So that one is actually also incorrect because interquartile range is actually Q3 minus Q1. And if you have that, you have Q3 minus Q1, which will actually give you 7. Okay, so in this question, that was actually also wrong. So there was a few in this that was wrong. So again, if something like this happens in exam or in your assignments, all the question will be dropped, or they will give you the points for that. Okay, so your interquartile range is your Q3 value minus your Q1, and that was 26.5 minus the 19.5, which is actually 7. The reason why they say the mode there isn't a number, because if you look at that data set, there is no number that happens twice. So in this instance, there is no number that happens twice. So there is no mode, because a mode you need to have at least a number that appears twice in your data set. Okay, so we started off with frequency. We then moved into central tendency when we only looked at medium, mode, median, and mean. Um, we then looked at it again, but just from another data set. And then we added your interquartile ranges into it. The other thing that one can then add, and let's see if it is, okay, still not. So I just want to add one thing for you guys in here. So if ever you need something else, so if you need, because those three was central tendency. So if you need the dispersion formulas included in here, you would have worked out your variance would have been 1. Because we are working with a sample, we use the sample variance in this formula set. So I just wanted so that you have that at least, and standard deviation. And then I also just want to show you something else. So standard deviation again, sample, standard deviation, because we're working with a sample. The other way to get to the standard deviation is basically to say your variance or the square root of your variance. So we could have done it as the variance of or your square root of a variance. So again, and it might be that we do a bit more of that in the next study unit as well, but if you need to do variance and standard deviation, again, we have used the same data set, which I've just built in that extra two answers for you if you need that. Okay, so let's look at the last question of these ones. Again, nearly we're looking at a data set that they want a few things, and especially again on quartiles and interquartile ranges and those kind of things. So let's look at the data. Also, what I want to show you with this one, that and let's just make it a bit smaller, it's just on the same. So the one thing I think also that you need to nearly always remember is, with a lot of these things or these questions in stats, they want to catch you out. So let's be honest in that. So so you will see suddenly here they talk value, position. So the chances is very good that one of these things will be wrong, because we've seen here position Q1 is 2.75. Now they suddenly throw in the value. So again, just be very careful when you're going through the examples or when you're going through the assignment, to see what we're talking about. So let's put in the data. I'm going to put it unordered in 51, 50, 47, 33, 37, 43, 61, 55, 44, 41. Okay, so you would have seen some of these data have now changed in the process. Keep an eye on it. I don't think it will. So let's see. I didn't know I want to sort it. I will. Why? What was the reason again? I didn't. Okay. Okay, so there's your sorted data. None of the other things have changed. So let's look at the first one, the value of Q1. So the value of Q1 is 40. So the position of Q1 is 2.75. So automatically this one is already wrong. I just want to check if I can get a pen or to write into this one. Doesn't seem like I'm can get a pen view, but okay, that's fine. So the first one is incorrect. Let's we'll get something that I can use. Even if it is that, let's see where I can no, okay, don't worry. Okay, so the first one was incorrect. The value of Q2, so the value of Q2, 45.5 is correct, which was also the value of the median. So again, we're happy that it is the same thing. So the incorrect statement would have been option 1. Okay, so option 2 is definitely correct, 45.5. Position of Q3 is 8.25. 8.25, we're happy with that. The value of Q3, so that's interesting. So why is that not 52? Yeah, so that is, so I think what is happening here is, so let's check where is 8.25. So that's 1, 2, 3, 4, 5, 6, 7, 8. 8.25. Okay, so what is happening in this instance, and you must check your book as well, is what they do in this instance in the book is that they round that off. So they round the position value off. So they round it off to position 8, even though they say position Q3 is 8.25. To get the value, they round it off to the 8th position, which is actually then 51 and not 52. 52 is, when you work it out by formula, it is the right answer. Okay, so I think I will also just ask the lecturer about the positions and how you need to work it out. If you can use this formula, or if you actually then need to round that off. So I will just make 100% sure for you. And then, see, so then what would have happened if that was position 3? That would have been 41. If that was position 8, it would have been 51. And then your interquartile range would have been that minus that, which would have been 10. Okay, so I will just check for you this to make sure that when you guys need to do it, that we probably will need to round it off. So I will just make 100% sure that we'll just make sure this is right and how to do it. Okay, so I will probably change in here something for you so that the value reflects what it should be. Okay, because again, if we work purely from the formulas, and they say position Q is actually 8.25, but let me just make 100% sure with the lecturer how they want you to use it. If you need to round it off, get to the closest number and use that number instead of 8.25 number. So let me just make 100% sure for you. But again, so if you look at that data set, there was again not one number that replicated. So there wasn't a mode. We saw the median was the 4.5. Even your mean is not the same. So in this instance, again, it would not have been symmetrical, but you can at least then also work out the variance and the standard deviation if it was asked for this set. Okay, so what we've nearly covered is mean, median, mode, Q1, Q3, interquartile range. We haven't really looked at variance and standard deviation. So I will get us for next time something on standard deviation and variance, where we actually look at the data set, and to show you the process of how we work it out. So there is that I just show you how the formula works to work it out if you need to do that at any stage in the assignment or in the exams, so that you have the Excel formula, but also the way it is structured with the formula that is given in the book. Okay, any questions for tonight? So that then the rest of, oh, wait. Huh, there's one more, sorry. So before we end, there's one more. So what this is, so the box plot, there's very little information in your study guide about box plots. And then suddenly in the assignment, there will be like 2 or 3 of these. So there is detail in the definition and work as well around box plot. Sometimes they call it the 5 measurement scale and all those kind of things as well. But basically what the box plot is, it summarizes your data. It summarizes your data into a minimum, and into a minimum point, a maximum point. That will be your Q1, that will be your median, that will be your Q3 value. So that's why they say it's nearly the 5-point measurement scale, because it looks at 1 point, which is the minimum, 1 that's the maximum, and it works out Q1 to Q2 and Q3. So basically 5 points into it. How I look at these, and you will, again, the data might differ between the different assignments, but I first look at this data set, and I want to eliminate before I start to calculate things, because to calculate now Q1, Q3 out of this and then more things takes time. So I'm like looking at this and I'm like, okay, 115 is the first point that I'm looking at. It's the minimum. So I'm looking at this one. I see minimum is 100, not 115. So I can eliminate. Minimum 80, not 115. Eliminate. Again, 100, not 115. Eliminate. Probably 75. It's even below 80. So it's not 115. I eliminate it. This one looks like it's somewhere in the range of 120, less than 120. It might be. Then the last one, smallest, is probably around 85. Okay, also not. So I basically have one that is the answer. So let's just look at the rest of the points. So 115, so that would be Q1 because there's 5 numbers. That would be Q2. That would be Q3. That would be your minimum, and that will be your maximum. So we have 15 as the minimum, but we also have it as the start of a box. So that's Q1 is also done. The median, you can see it's 120. It's done, it's all right. So we don't see a number here, but that is about 125, which is your Q3, and your last one, your maximum is sitting around 150, which is also correct. Now, again, so that was, let's say that's easy. You say, E, and then, box B. Oh, no, I was actually looking for box E. So again, so just be careful that, so we're actually looking at box E. Box E is option C. Okay, so again, feel stupid. It should not be like that. It should not be where they try to catch you out because you actually knew that you want E as the answer. But just be again careful. And this was one of, what was it, 2021, one of the online assignments, one of those questions. So just again, be careful that you're looking for box E. The option was actually to say C. So okay, so that is the last of the study unit 3. You will see, so what I've added now is all of the formulas, all of the extra information around this, a bit more that you can look at. What I will do for you for next week is I will go not through this. I will look at the previous first assignment. Okay, so here was that box and whisker. So I will go through one of the previous assignments, and we can go through that as prep for your first assignment. So we will do that next week. I think for 1610 have a bit more time than with 1510s. So I think 1510 is the week of the 23rd of May or something you need to end in. So next week we will just do a 2-hour session on prep for the first assignment by going through the previous assignment from one of the previous years. So it's basically prep for both 1510 and 1610. Okay, any questions for tonight? all happy. Cool. I will also see if I can download this in and add it to our chat on WhatsApp. And if you want to still join our WhatsApp group, please send me a WhatsApp on 0837908387. Okay. Thanks everyone. Have a good evening and we'll chat soon again. Cheers everyone.
Thank you. Cheers.